Hello everyone. In this video, we will be talking about test of two variances and or standard deviation. We did test one variance and one standard deviation in another video, and at that time we introduced another distribution, which was the chi-square distribution. When we test two variances or two standard deviations, we need to introduce another distribution, which is called the F distribution. If two independent samples are selected from two normally distributed populations in which the variances are equal, and if the sample variances S1 squared and S2 squared are compared as S1 squared over S2 squared, then the sampling distribution of the ratio of the variances is called the F distribution. So this is what Fisher did. It compared a ratio, the larger variance on top and the smaller variance on the bottom. Let's just talk a little bit about the properties of this distribution. This distribution is a family of curves. This time we have 2 degrees of freedom. Degrees of freedom of the numerator and degrees of freedom of the denominator. You can see that each curve in this visual has 2 degrees of freedom. You can see that this distribution is skewed right as the chi-square distribution, which can be seen in this graph. And you can see that we have only positive values for F. 100% of the area is under the curve. It is created by the ratio of two variances. The mean value of F is approximately equal to 1. This is where the mean value of F is. And we can figure out critical values from a table, but that table has many pages. So when we do a test of two variances, we will set up the hypothesis accordingly, and then we will be looking for the test value. So the test value for an F test, which is a test for two sample variances or standard deviations, looks like this. S1 squared over S2 squared. You'll want to make sure that always the larger variance is on the numerator. The degrees of freedom of the numerator will be N1 minus 1. Degrees of freedom of the denominator will be N2 minus 1, where N1 and N2 will be, of course, the sample size for each one of the samples. Again, note for the use of the F test. The larger variance is designed as S1 squared, and it is placed in the numerator. For a two-tailed test, alpha must be divided by 2. And the critical value, if you go through the critical value through the table, should be placed on the right side of the curve. If the standard deviation, instead of the variances are given in the problem, they must be squared for the formula for the F test. When the degrees of freedom cannot be found in the table F, this is if you use the table to find the critical values, then the closest of the smaller side should be used. We will be doing these problems using the p-value method. But in case you are curious and you want to look at an F table and identify the critical values and do problems based on the critical values, feel free to do so. So the assumptions for testing the differences between two variances are: the population from which the samples were obtained must be normally distributed. The test should not be used when the distributions depart substantially from normality. The samples must be independent of each other. All the calculations for testing the equality of two variances can be easily done on the calculator. Go to Stat, Tests, and pick to sample F test. Like most tests, we can either enter the data into list and then use the data option, or we can enter the summary statistics. Let's take a look at this example. A certain clinic compared healthy dogs it owned with healthy pets brought in to be neutered. The summary statistic for blood cholesterol levels, milligrams per deciliter of blood, are as follows. The pets that were brought in have these summary statistics. The clinic dogs had these summary statistics. At the 0.05 significance level, is there significant evidence that pets have more variable cholesterol level than clinic dogs? So based on this, we are looking at variability, meaning we are testing variance, and I will be looking at the pets and clinic dogs. Because I know this is an F test, I want to make sure that I will have the larger variance on the top of the fraction. And it seems that the larger variance will be corresponding to this. So I will denote this as 1. Okay, so S1 will be 68. And this is for pets. And S2 will be denoted with 44. So it says right here, is there evidence that the pets have more variability than the clinic dogs, which means sigma 1 squared is this greater than sigma 2 squared. These are the corresponding parameters for S1 and S2. So let's write down the given information on a side. What we have given is the summary statistics for these two categories. And I'm using 1 for pets and 2 for clinic dogs. I will not copy it down there, but this is what we know. We know alpha, which is 0.05. And here is the question, which means we are testing the variability, testing two variances. So we know right away we have to do an F test. Similarly, we can actually say that we are testing two standard deviations and write this as sigma 1 greater than sigma 2. Either way, we are doing the same test. So let's go ahead and set up the test accordingly. So I will do this using the p-value method. So step 1, set up the hypothesis. H sub 0, H sub A. Because I'm testing variability, I can use either one of these. Just keep in mind that we denoted the first category pets using the subscript 1 and clinic dogs using the subscript 2. So I'll write down the H sub A using sigma 1 greater than sigma 2. And of course, you can do sigma 1 squared greater than sigma 2 squared, right? While H sub 0 will then be sigma 1 less than or equal to sigma 2. And this is a right tail test. And this is the claim. Step 2, we know we are using an F distribution because we are testing variances and or standard deviations. This distribution comes with 2 degrees of freedom, n1 minus 1 and n2 minus 1. We can write that down, degrees of freedom of the numerator and degrees of freedom of the denominator, just to be correct. So we have the formulas n1 minus 1 and 2 minus 1. Since we use this one as the first one and this one as the second one, we have degrees of freedom for the numerator, 39, and degrees of freedom for the denominator, 33. Oh, 33 minus 1, which is 32. Okay? And now we will simply do the two sample F test and look at the results. And we'll write down the results right here. The F test statistic, which is S1 squared over S2 squared. Okay, we can do that right away, squaring 68 and 44 and do the ratio of those two and the p-value. But we will do that using the calculator. So let's take a look at this work on the calculator. On the calculator, we have test. We will go to the other screen when we see the 2SEMP F test and then hit enter. And we have statistics and we simply plug in the information that we have here. S1 is 68. The calculator requires S1, so we have 68. N1 is 40 and S2 is 44. Make sure you plug in the correct numbers in the correct place. And then we have 33. And we are doing right-tailed test, comparing the two standard deviations or variances. And I will calculate. Here we go. We have S as 2.39 and the p-value 0.0066. Let's write that down here. And I can continue now with the test. This will be step 4. The p-value is 0.0066, which is less than or equal to 0.05, which is alpha. I should have written down this in here. I put this down here, which means we reject H sub 0. So at step 5, I will say at alpha equals 0.05 level of significance, there is enough evidence to support the claim that pets have more variable cholesterol than clinic dogs. And this is how we conclude a two-sample F test. Take a look at another example. You may want to try to stop the video and do this first and then compare with what I'm going to do. A restaurant manager is designing a system that is intended to decrease the variance of the time customers wait before their meal are served. Under the old system, a random sample of 10 customers had a variance of 400. Under the new system, a random sample of 21 customers had a variance of 256. At the 10% level of significance, is there enough evidence to convince the manager to switch to the new system? Let's write down the given information. And we know right away this is about variance, variability, decreasing the variance. And we have the information, one system, this is the old system. So let's just write down old before we will use 1 and 2, okay? Just the old system. We have this information, n is 10, and the variance, which is s squared, would be 400. Under the new system, we have a sample of 21 customers, and the variance, 256. Now, we know we are doing an F test, and we know that in an F test, the larger variance should be denoted with a subscript 1. So the larger variance right here should have a 1. That means the old system will be denoted with 1, and the other system will be denoted with 2, subscript 2. Next, we have a 10% level of significance. That means alpha will be 10% or 0.10. And keep in mind, we're looking for decreasing the variance, which means we are testing and we're answering actually the question that sigma 1 squared is greater than sigma 2 squared. So we will be doing a test for the variance this time, comparing two variances. This is equivalent with testing standard deviation 2. So keep that in mind. These two tests are actually one. The notation, though, in this case, we will be keeping it variance because they are very specific there. So let's go ahead and write down the steps. Step 1, the hypothesis, H sub 0, H sub A. Right here we have strict inequality, so that will become the second or the alternative hypothesis, which means the first one will be sigma 1 squared is less than or equal than sigma 2 squared. Again, we have a right tail test, and this is the claim. Step 2 will be to make sure we know we are using an F distribution. An F distribution comes with 2 degrees of freedom of the numerator, degrees of freedom of the denominator. Now, on the top for F, we put the larger variance, which is S1 squared, and on the bottom we'll put the S2 squared, which means then on the numerator, the degrees of freedom will be related to the sample size, which is 9, and 1 minus 1. And on the bottom, we have n2 minus 1, which will make degrees of freedom on the denominator equals 20. Also, I'll write down that alpha in this case is 0.10. And we are using the two-sample F test because we are testing or comparing two variances. Let's do the test and find the test statistic F along with the p-value. Here we have the calculator, go to test, use arrow to get to the other screen and go to two-sample F test. Hit equal. And we have again summary statistics S1. And this time they ask us for S1. I have S1 squared, so I will do square root of 400. Make sure you enter S1, okay? N1 was 10. S2, I will do the square root of to 56 and N2 is 21, we are doing a right tail test and hit enter. And this is what we have. F 1.56 and P, this is a very large, it's a large P. So let's write down the findings. Test statistic F is 1.56 and the p-value is 0.1939. With that being said, we are ready to make a decision based on the p-value method. Step 4, 0.1939 is greater than 0.10. So we will fail to reject the null hypothesis. And that means at 0.10 level of significance, there is not enough evidence to support the claim that the variance of the time, and you can simply copy this down and put it here, and then continue with has decreased. To answer the question, there is not enough evidence to convince the manager to switch to the new system. I hope this makes sense. With this, I conclude the video. Thanks for watching.